Hello everyone. So today we are here again to do some Rust, and we are gonna do Advent of Code as usual. My name is Luciano,
Roberto.
Jen.
and last time what we did was exercise number 12, part 1, which I'm gonna be showing in a second, but basically was an interesting one where we needed to move a ship, and basically we had a bunch of instructions on which direction we needed to go, and eventually at the end we needed to calculate the final position of the ship. So today we're going to do the second part, which I suppose is going to be a variation of that specific exercise. So let me share my screen, and we'll go very quickly. Let's review part 1. So basically we had this ship starting at let's say 0 coordinates, and the ship can move north, south, east, west, or rotate left or right, and you can also move forward depending on the current rotation of the ship. And basically at the end you will get instructions like this, which means, for instance, go forward of 10 units, north 3 units, forward 7 units, rotate 90 degrees on the right, and so on. And then these are just a bunch of examples. And at the end, we needed to calculate this Manhattan distance, which is basically the sum of the absolute values of east-west and north-south positions, so basically x and y coordinates. And we did all of that. I don't know if we want to review very quickly our solution. That might be useful to figure out what we want to change.
It would be good to at least remember what we did.
Exactly. Yeah. I'm not sure I remember myself, much. So let's see. Oh, did I pull my latest changes?
Probably not.
I don't think I have them. Did we commit them, first of all? Because last time we had Javier doing stuff and driving. So let's see. Let me see if I need to pull.
I just pulled and I got some changes.
So probably I didn't pull. So just give me a second. Okay, magic. Yes, now we have the changes. Right, so okay, what we did was we created an enum for actions, which was basically directions plus rotations plus forward. So all the different types of movements we can have. And then we also implemented a from string. So basically we can convert easily the character into the specific enum variation. And then we had an instruction, which is basically a combination of an actions and a value, because generally you say, I don't know, forward 5. So action will be forward and the value will be 5. Then what we did, we implemented a new. For that, we implemented we left this into to do. I think we wanted to do this and then we didn't do it, so maybe we can clean this one up later. But we implemented a from string eventually. Yeah, so I think we can remove this one. This was just as an example. And then we created a ship as position X and Y and a specific direction. It starts from 0 and direction 0. Direction was the degrees to which is facing, basically. The direction is facing. And then we add this functionality go that will take an instruction and figure out how to move the ship.
Important note about ship's direction. We decided 0 means facing east or facing right, depending on how you want to look at it.
All right.
And we went clockwise. So like 90 was south, 180 was west, 270 was north, right?
That makes sense. Yeah, that's a good thing to remember, reference point. And then Manhattan distance is something that we implemented directly on the ship. Okay, so that kind of makes sense. And then what we did was, literally we say, take every line from the input, do a for each, and then we parse the specific line. This will give us an instruction because we implemented the from str trait, which gives you this parse feature. And then we always know we succeed because we don't expect input that is not formatted correctly, so we can just unwrap, and we pass that value to ship go. So this loop for every input line is going to update the position of the ship, and then at the end of the loop, we just return the Manhattan distance. And that was our solution number 1. Now for part 2, let's see what is the difference. Okay, part 2, let's see. Before you can give the destination to the captain, you realize that the actual action meanings were printed on the back of the instruction the whole time. Almost all of the action indicate how to move a waypoint, which is relative to the ship position. Okay, so basically now, rather than moving the ship directly, we are moving a waypoint. And let's see. Okay, this seems all the same. So N moves the waypoint north, not the ship, but N still means north. S still means south, but moves the waypoint. East, of course, E is east. W is west. L rotates the waypoint around the ship left, counterclockwise, or rotates the waypoint right, clockwise. And F, this is probably the main difference, means to move forward to the waypoint a number of times equal to the given value. So if I am understanding this correctly, now rather than moving the ship directly, we are creating a vector, like as a reference, so which will be of a certain length, and it will be facing a certain direction. And then every time we find F with a given number, that means apply that vector to the ship a number of times. And it's saying the waypoint starts 10 units east and 1 unit north relative to the ship. Right, okay. So the waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it.
Okay.
What does this mean?
I mean, I think the vector is always applied to the ship. This is not important. If you think of the waypoint as an X and Y, that is a vector, and then you have just apply. When you find F, you have to apply F times the vector to the ship.
Both the ship and the vector relative to the ship.
Okay, so we can probably imagine the ship as a dot and the vector, which is always starting from the ship, basically. And if the ship moves, the vector is always moving together with the ship. So it's like a cursor that indicates the current direction that the ship.
Exactly. And the rotation is not applying to the ship, so the ship doesn't need to have a direction anymore. The direction is on top of the vector, not on top of... so the direction is not even needed to be memorized in the vector, because the vector is X and Y, and when you rotate it, you just manipulate the coordinates.
Oh, yeah, that makes sense. Yeah.
That's true.
Yeah, we'll need to figure out the maths around that, but it's probably
This is interesting. It makes me wonder about the direction of the ship, because this means our ship, in the first iteration of this exercise, our ship had basically pretty straightforward directions. It could go east, west, north, or south. I don't think we had anything like 45 degrees, like moving diagonally or anything. But with this, it means that we can have all sorts of random directions, right? We could technically have it facing 10 degrees below straight east, right?
Yeah, but the input is the same. So the rotation of the vector will always be the same, 90 degrees. So a number of times that you rotate it.
Yeah, but moving the ship towards the vector is what I'm thinking about.
Yeah, but you just take the coordinate of the ship and you add the x of the vector and the y of the vector, and you move diagonally of the needed degrees. You don't need to compute the degrees.
Yeah, I think the rotation will be trickier to figure out exactly how to swap the values of x and y to rotate, but it's always a multiplier of 90 degrees. So I think you just need to figure out whether you need to swap X and Y and probably change the
sign.
signs as
Yeah.
well.
So
For
I'm
example,
not-
when you rotate 120, you just invert the sign of X and Y, and you are done.
that's
Because
fine.
if it's
So
10-10, it go to minus 10-10. If it's 10-1, you go to minus 10, minus 1. And this is 180.
yeah,
Then
but that's
90 and choose 7.
That's rotating the vector, that I can understand as in our waypoint, and that's perfectly fine. My question is for moving forward to the waypoint, right? So this is when our ship, from wherever it is on the grid, moves towards the waypoint wherever that is on the grid.
There is the first line 61 that explain that. The line 61, F10.
Yeah, let's read this example.
Okay, that would be good.
It might clarify what we need to do. So let's say that the same instruction as above, which they start with F10. And we also need to remember that the waypoint, it's always 10 units east. So it means we can assume it's 10 on the x-axis.
Yep.
And 1 unit
On the
north.
Y.
So it's -1.
No,
right?
1.
Did we say 1 goes?
We'll check. Anyway, regardless.
Yeah, okay, let's say it's either 1 or -1. We'll check exactly what reference point did we pick for the y-axis.
I think for the solution is not changing anything if we are consistent.
Oh yeah,
because the Manhattan distance is an absolute, so it's changing nothing for the results.
So basically, you have the ship that is at 0, 0 because it's not said otherwise. So we can assume the starting point is 0, 0. Then you can imagine you have an arrow going from the ship, 10 units on the right, and 1 unit north. So that basically means F10 is going to apply that arrow 10 times. So it's going to go east. So we have east that is 10, the arrow. So we need to apply that 10 times. Okay. So it's going to increase by 100. And north, which is 1, multiply 10, is going to move north 10 times.
Okay. This is a lot simpler than what I had in mind. This is nice. So in my head, what I understood from the initial description was we have the waypoint and the ship, which is basically the ship is stationary, the waypoint kind of moves around and changes the pitch of the ship, if you will, or the angle at which it goes. And then F, when you have an F10, it means you move 10 units in the direction of the waypoint. That's what I got. So you don't apply the waypoints X and Y, which was strange because I was thinking, right, if you have 10 to the east and 1 to the north, that means you have like a very shallow angle. So it would put you in between the grid somewhere.
It's way simpler. No, it's way simpler. It's not move 10 units side, it's apply the vector 10 times.
Easy enough. Okay, cool. I got it. Fair enough. So okay. Perfect. Thank you.
Cool. So that's basically what we need to do. I think it's clear enough, right?
Yeah.
And basically at the end, we need to, again, at the last instruction, we move the ship. We need to retard the Manhattan distance at that point of the ship. So we can probably keep our ship as it is. We'll probably need to have a method that is not go. Remember that we had this method called go just to move the ship. I think we can just use X and Y,
But we can pass a waypoint and a multiplier. We can have a function called sail. I have no idea how to call it. Let's say sail or go to or sail, and you give it a vector that is a class that you have to create, or that is called a waypoint. Sorry, so we call it waypoint, and the number of times to apply the waypoint.
Fair enough. So we can do that. And we also need to create a waypoint abstraction.
Yeah, we have to create a waypoint abstraction.
Okay, so let's
start with the waypoint.
Let's start with the waypoint. Let's do it here. So we can create a new struct waypoint. And waypoint is going to have X
and Y,
which is
signed.
Signed.
Yeah. Let's say I32, I suppose, and Y it's I32. And do we need anything else? No, because we'll need the rotation and the rotation is something that will mutate X and Y. So we don't need to store a specific rotation.
Exactly.
So what we can do is implement waypoint, waypoint, and we can say fn new, and this is going to return a new self. And here what we want to do is waypoint, and we know that the defaults are X is 10
Yeah.
and Y is 1.
Yeah.
And that's it. Now,
Then we
Y-
can implement the rotate.
exactly. Then we can implement rotate.
And start to think about the math. But
FN, or do we
And
not need
we
FN?
we will have degrees, right? So we will have degree, which is, again, we can say an I32, because will be a number between,
Do we not need to put FN before the definition here?
yes, thank you.
Cool.
And this also, the important thing is that this take a mutable
Self.
reference to self, because it's going to mutate itself. And it doesn't return anything because it's just mutating itself. Right?
Correct.
yeah.
Yeah. My Rust analyzer is very slow.
In our input, we have rotation of 90, 180, 270, and also negative 90, negative 100 is like 100.
We have left and right rotation, so you can assume
okay,
that
true.
left, I suppose, is negative because you go counterclockwise, and right is positive because you go clockwise.
Okay.
Now, what is the math for this stuff?
We have a 360 or never a 360?
No,
It
never.
seems
We
to
have
be 90 and 180.
180, even 270.
Did you see any? Because I
Yep.
haven't.
We have it in the input. Let's
Oh, yeah,
double
there
check
is.
because it's a good question.
You're correct. There is a
Oh my
270.
god, this is tremendously slow.
I'm sorry.
There you go, 270.
But there's nothing over 360, though.
Is
No.
there 360? No,
No.
not 360. Okay. Just to know. But okay, the 360 you do nothing because
Yeah. Yeah, go around in circles. Why not?
Yeah, to be fair, one dummy way we could do this is literally listing all the options. We will have 6 cases, right? It's
Yeah.
plus 90, minus 90,
Let's
plus
do-
180,
let's-
minus 180, and plus 270, minus 270, right?
Do
Yeah,
we
do
not
that.
want to
Let's-
base this on the instruction as we had it before? Because that contains whether it's left or right, and then the degrees as a number.
We could do that, but the problem is that for us, an instruction is everything. Can be even north, can be...
Ah, yeah, true. We need to. Yeah,
But
you're right.
the waypoint also has to react to north, south, east, and west. The only stuff that the waypoint is not reacting to is the forward, that is for the ship. All the other commands are for the waypoint. So we can, instead of having a rotate, we can have a more general execute command.
Yeah, move, take
Yeah, like
instruction,
move
whatever.
waypoint or something like that. And rotate will be called by that move.
Yeah.
Exactly.
Okay, by the way, I just want to say hello to Tommaso, which helped us a lot in the previous edition where we did part 1 of this exercise. So, Tommaso, don't be shy and help us this time again.
But well,
Alright,
let's start like you were saying with a match with from minus 270 to 270.
Let's say move as well, where we have move. We said we cannot have move, so let's call it
Apply instruction.
transform.
Go transform. Yeah.
Transformer.
And it's a mutable reference to self. If I can spell.
A meet self is a mythical self that
Mythical self man mont.
Yeah.
And then instruction, which is an instruction. Oh, this is so slow that I cannot spell.
You can tell we had a long weekend.
Look at this, it's taking forever to... And also, why it's running ESLint, I have no idea.
Mhm.
That's
Alright.
really weird. Okay.
So you need a new laptop, which
I probably need to, use a different laptop.
Remember the
Okay, do we
Patreon.
start
Send
with
5 euro to
rotate?
Luciano.
Yeah, let's start with this guy. So we say match
Mhm.
degree, and basically the options we have. Why do I keep putting parentheses? Sorry, JavaScript. And the options are 90, and this will do something.
Mhm.
Then we have minus 90, and this will do something else. And then we have 180.
Do we want to go with the minuses as well? Because we could pick the opposite, basically. If you say left 90, it's the same as saying right 270.
Yeah, true.
Fair enough.
It might be an early
Okay.
optimization, though, so your call.
But we will
Let-
try the same code in the brackets, so we'll... Okay,
let's start with this tree, and then we'll figure out whether we want to do something that uses only this tree, or we list all the minus.
Okay. 180 is the easiest.
And then basically, I just want to do this one. Oh, Thomas is saying 0. I don't think 0 applies, because this is just to recap, because maybe you missed the first bit. Now the exercise is a little bit different. Rather than having rotation for the ship, we have like an arrow that points where the ship is going, like a vector basically, that starts from the ship and has a certain width and a certain direction, and we are just representing that with X and Y. But then this waypoint itself can rotate, and every rotation will change just X and Y basically.
But 0, we do nothing, and we are in the default case that is...
Also, in the input set, there is no left 0, right 0. Which I know, technically, if we were to implement this correctly, I think we wouldn't be doing a match on degrees.
Yeah.
But if we were to implement it correctly, we should also handle the 0 case, right?
Start with 180, that is the easiest. You invert the sign of the coordinates. Done.
Exactly, both of them.
Yeah, both X and Y, you have to invert
So
the
basically
sign.
we say self.x equal self.x with a minus. How do you do that? Like this?
Or you multiply by -1, that is getting the...
I'm just curious to see if this works.
Okay.
And we probably need a semicolon there.
Yeah, and do the same for Y.
Yeah, it seems that it's not complaining, but since my laptop is super slow, it might complain in half an hour. So we do Y. Jesus.
Self-X.
Oh, this is terrible. It's very laggy for me, so it's hard to be accurate. Okay, so this is the easiest case. Now, when we do 90, what are we doing? Are we just swapping X and Y?
Now 90, let me think, 90 is rotating clockwise, so we are taking clockwise. So if we have 10, 1, it will become 1 minus 10. So the Y, the new X is the old Y.
Mm-hmm.
And in the meantime, you have to do an assignment in the same moment, because otherwise, so or use a temporal variable.
Yeah,
or
then we need a temp, TMP.
Yeah, in Python, you can do assignment in the same moment to shoot different values. I don't know if in Rust you can do that.
Maybe, but I don't know that, so let's...
Okay, save X for now. Save X for later. And now assign to self X, self Y.
Can you? Because I think it's...
Yeah. And the new Y is minus the old X. So self of Y is minus temp.
Now, when you assign self.x to TMP, is it going to assign it as a value or as a reference? It should be a number, so I think it's going to be value, right?
I think it's a value, yeah.
Also, you have to do let, you have to do something in front of TMP. No.
I mean, yes, I don't know why it's not complaining. Okay,
Okay.
starting to complain here. But I don't know. Right, then 270, is it just, is both swapping and changing both?
No, it's like 90. It's similar to 90. So basically, because it's the inverse, inverse
Right.
sign of 90.
Yeah, it's
So-
left 90 instead of right 90.
Yes,
Yeah.
so this is self.y, and then self.y is, sorry, self.y is self.x.
Mhm.
Okay, let's think. We have the new y that is the old x, right? Yeah.
And now self.x is equal minus temp, right?
Yeah, exactly.
Mhm.
Cool.
Okay.
Now, when we have right or left rotation, we have just to pass the right numbers, because a right 90 is like a left 270,
Mhm.
and vice versa. 180, we don't care, because left or right, you're always going 180.
Fair enough. Okay, so that's it for the rotation. Now, transform, what do? We need to do a match on the type of instruction, I
Yeah.
suppose.
We can probably copy it from the ship's Go, because the X and Y ones are going to be
Good
the same.
point.
Yeah, the only instruction that we don't have to care is the forward, that probably we can pass the instruction even if it's a forward, and just the waypoint is doing nothing for a forward, is don't taking care.
Yeah.
Underline, I don't care.
Okay, we can see if there is a more elegant way later, because I
Yeah.
think we are like keeping the code exactly the same. It's forcing us to.
Let's go to a working solution, then we can think if
Yeah.
there are optimization on top of that.
Make it work, then make it pretty.
Okay. There you go. Sorry if it's very slow. Right, so what are we doing here?
North is fine. South is fine.
East is fine, west is fine. Now right and left is where we need to call the rotation method, right?
Exactly.
So for right, we just call it as it is, right?
Mhm.
So we say
For right, yes, we call it
we
self-rotate.
just say self.rotate, and the value is instruction value, and that's it.
Exactly. And the other one, I think, should be 360 minus instruction value. We're going left.
Yeah, at this point, it doesn't matter. Like, we don't need to normalize anything, right?
Oh, no. Yeah, for this one, it's fine. Yeah, I'm just
Is
thinking
the
about
other one that we can trick using the trick.
So here we do rotate, where
No, sorry. Right is counterclockwise, and left.
no,
Plus,
left is counterclockwise. Right.
So yeah. Sorry. Left and
we
right
can
are still
do,
left and
so-
right are still hard for me.
with this one, we can still do a different kind of trick. So we can add 180 to it. We can
Yeah,
add 360
and
to
modulo
it.
360.
And modulo 360, yeah.
We can add 180 and modulo 360.
I would
Okay,
add
so
another
we
three.
do-
we
we do-
don't need.
instruction.
No, wait. We can do 360 minus the value modulo 360.
Yeah. Well,
Yeah, because 180 must stay 180.
yeah.
So 360 minus the value, everything modulo 360. No.
Can this
360.
become negative?
It can, yeah.
Well, with the modulo, we'll make it positive again.
Yeah, 360 minus any of these
Minus
is
the
going to be positive.
360 minus the value. But you didn't wrote what we say.
Yeah. You're removing 180. I can't draw on your screen. So inside the thing. there,
360 minus instruction value.
All right, okay. 360 instruction.value, and we don't need 180. Or we
Yeah, we
also
don't
remove
need-
180.
No,
No,
the
no,
180
no.
was an accident.
Okay.
We also need parentheses to be moved to later,
Yeah.
because you're moduloing self.rotate instead of
Yeah.
the.
Open two brackets, round brackets, when there is the rotate open, and
Okay.
close it after the 360. Open a new one there, okay?
Oh,
and close
yeah, I see now.
And close one after 360. Okay, now they must be balanced. Yes.
Sorry, Luciano, we confused you, and your editor isn't helping either.
And
Sorry.
for forward, we do nothing.
For forward, we do nothing.
Because it's not an instruction for the waypoint. Forward is an instruction for the ship.
Yes, okay.
Can you do nothing? Yeah, you open and close, you do nothing.
So
You
let's
can even do like an
say
underscore and go.
this doesn't change the waypoint.
Should we not be handling this at control loop level and technically not
If,
pass this forward to it?
If we want to keep the control loop simple, we loop over the instruction, we pass the instruction to the waypoint and to the ship, all of them. Then the waypoint will work is once, and the ship will work is once. So only forward is the only one that ship works. And to the ship, we also have to pass the waypoint because it has to apply. If it's F, it has to apply the waypoint. If
The
we
only
don't
problem-
like, if we don't like this, we change it later.
The only problem with this is we need to modify the ship, which won't work with the first problem anymore.
We add another command for this for the second part. We don't use go.
Okay.
We use sail
Or go to.
or go to. Yeah, in
Um,
the navy.
So basically, if we want to write the loop there, it's gonna look more or less like this, right?
Yeah.
Let's mute
Waypoint.
ship.
Yeah,
This
also.
is gonna be ship new.
mhm.
And then we
And we're
need
gonna do let mute
Or
Waypoint.
might.
waypoint new. And then we do the same stuff that we do here, but instead of calling ship go, we should do a condition that checks whether the instruction is forward or not. And we call either the waypoint or the ship.
We can do
Right?
that, or we can always call both of them, and they will handle the commands internally.
Fair enough. Let's keep it simple. So we need to parse the instruction. Let's do it in another thingy. So let instruction equal this, and then we do
We do waypoint with the instruction.
dot
Transform.
what did we transform?
Transform, I think it was called.
Instruction.
Instruction.
And should go to waypoint of waypoint and instruction, I guess.
Yeah.
Go
to. I don't know. Go to. Waypoint.
Or let's call it apply waypoint.
Apply waypoint, yeah.
And we are giving an instruction and a waypoint. And a reference to the waypoint. Sorry, not the waypoint.
And now this is the one we need to implement.
Yeah.
Well, and at the end, this is going to be the same, right? Ship get Manhattan
distance. Ship get Manhattan distance.
Let's go to the ship. Ship.
A sheep shipping sheeps.
Exactly.
Let's ship it.
Yeah.
Now let's do this function. So this function, we can implement it in
the ship.
There. Stop. There. So let's say for part 2, 12, 2, fn
It's full of parts, this test.
This guy is... Oh, now instruction needs to be a reference as well.
Yes.
Yeah, because otherwise we are eating it with the waypoint. Cool.
And this guy will be
A
a
reference to the
reference to a
waypoint.
waypoint. And it doesn't return anything. It just...
No, it's a changing.
it needs
is
a reference.
mutable self.
Mute self. Again, mythical.
Mhm.
Right. So here, what we want to do is again a match.
That is
Do you
only
wanna-
matching the forward, the instruction.
Before any of this, do we want to make sure we're passing references to everything before we forget and it fails?
But well, the
we'll
linter
do in a
will,
second.
Rust Analyzer will tell us something, I think, down in the loop.
Action.
Okay.
And we do forward.
Forward.
Uh,
That is the only one that we
we need
match.
to do use action there.
Mm.
If we just want to say forward.
Okay, true, because otherwise you have to do action dot for dash dash dot dot. Oh, colon.
Jesus, this is
Dot, dot, dot,
horrendously
dot.
slow. I'm just gonna, because we have only one, I'm just gonna do action forward.
Mhm.
And here, what we want to do is
Self.x plus
this
equal.
doesn't do anything.
Yeah, that is doing nothing.
Nothing to do if not forward. And basically what we are doing is
Self.x plus equal waypoint plus equal, not equal plus. But well,
yes, you're right.
I hope that Rust is not implementing the equal plus. Waypoint.x multiplied by instruction.value. Is an integer instruction value?
Yeah, it is.
Okay.
It's yes,
It's
it is
signed.
unsigned
Oh,
integer, so
unsigned.
probably we need to do this.
But well, you can multiply signed and unsigned. It's not illegal, I think. At
I'm not
least
sure. Let's see with Y what it does.
in assembler is not illegal.
Let's do this and let's see if it complains. In
15 minutes. Yeah, okay.
Give it 5 minutes to run.
Remember to send €5 to Luciano for his new laptop.
Yeah. Seems happy so far, so I suppose we can remove this. No, spoke too soon.
Can
Didn't
you
waste
add
my 5 minutes? Okay.
Nice.
I 32.
Well, okay.
Oh, well.
Okay. I think also in the loop down there is complaining about borrowing and
exactly, yes. Yeah,
reference.
That issue there.
Mm-hmm.
And we'll probably need to change
The interfaces to all of these.
So this is going to be an ampersand instruction, but we'll need to change transform as well.
Yeah, we have to change transform too, otherwise transform is destroying the instruction.
So transform becomes a reference to an instruction.
Beautiful.
Now it's still red, so let's see if it's just lag.
It's not red on our screen, or mine at least.
Not even on mine.
There is a little square thingy here that is red.
Can't see it. On the edge of the screen.
Okay, cargo check is running. Oh my god. Suspense.
Okay.
Now it's gonna take 20 minutes to compile, and then we'll see it next time.
Yeah.
There are another. Oh, maybe this is just the Git. Whatever. Let's run the test.
Stay tuned. Next time we'll see the compilation. I have to say that Rust is incredibly fast when it runs. The Rust Analyzer is beautiful. The compiling time is painful.
Yeah. This is one of the main complaints that
probably the compiler is made in Python for this reason. It's so slow. In theory, you can write a compiler in Python that output machine
Absolutely.
code.
Yeah, I think it's slow because it's doing a lot more stuff, checking all the various rules of borrow checker and things like that. Okay, look at this beautiful building.
Mhm.
Look how fast it's progressing.
Can I ask what is doing your CPU in this moment?
Actually, let me pull the task manager.
Are you experimenting with Bitcoin miners right now?
Yeah, probably it's time to turn
Probably.
it off. You have to turn it
Probably.
off when you stream.
Yeah, I think I have. By the way, every time I'm sharing my screen, it becomes horrendously slow. So I'm not sure if there is something wrong with my GPU or whatever.
Might
But,
be.
you can stop the sharing, compile, and share again.
Maybe, yeah. Let's see. Let's
Yeah,
see if
try
that
it.
helps. I cannot even click stop share.
So, is it any faster?
It's still there at 0.
All right.
I might do a git commit and leave it to somebody else to compile.
Okay.
Yeah, I'm
You can run it if you
cloning.
want.
I'm cloning the repo.
I have it pulled. Well, I can pull Luciano's once you commit.
I don't know if you
Let me
commit.
commit meanwhile.
Okay.
Commit and push,
Yeah.
and I'll run them. See if Roberto's can clone it faster than I can pull.
He's asking my MFA to access GitHub, so it's not that fast.
Let's see how quickly Luciano pushes as well.
That is true. GitHub. What is my GitHub?
Okay, it is pushed. It's funny that it's still compiling, by the way.
Okay. Get pull. Yeah, I got the code. Okay, let me share then. Where is
Okay,
it? Share.
let's fall back on Eugen.
New.
Oh, it's compiling and it panicked.
Oh, do you want to go back to sharing? Or
I want to see why it panicked. Oh, because we are returning the wrong value, so we did something wrong.
Perfect.
do I share? Or do you want to
you
keep
share
sharing?
because otherwise will take forever to try to debug this. If you don't mind.
Share the screen. Allowed. Okay, share. Share screen. Where is it? Roast Advent. All right, so I presume you can see it now.
Yes, I need to enable it.
Cool. So why?
Make the font a little bit bigger, if you don't mind.
I will, of course. Is this better?
A little bit more.
Wait, wrong button, sorry. Is this better?
I think this is good, yes.
Yeah, fine for me.
So people, let us know in the chat, please, if you cannot see this.
So what is happening? We are applying the thread instruction. We are applying instruction and waypoint. We are rotating it correctly or not? Good question.
I'm not getting the roast analyzer commands though. The run test and stuff. Haha. I think I have an issue as well. You added it to, where was it?
Oh, you need to, do you have the plugin enabled?
I should have it here. Where is it? Roast analyzer. Yeah, it's enabled and installed.
Okay. Try to disable and re-enable it, maybe.
Yep. Reload required. Okay. Am I still sharing?
Yes.
Cool.
Now you need to re-enable it.
Yep. Enable.
Okay.
There's a new
Download
language
now
version.
for some
Okay.
reason.
Let's hopefully we can run it today. I genuinely there we go. Run test. Cool. So let's see.
So we have it wrong for some reason.
Okay, there we go. We have an actual failure. So let's see why it failed. Assertion failed. Oh, it was just a different number.
So we are doing something wrong. What are we doing wrong?
So
I'm worried that maybe it's something with the rotation.
I would think so as well.
So let's recap. 180 is simple because you go the other way around. You mirror stuff. Cool. Fine. 90, you go like this. So the old X is becoming the new Y negative, and the new X is the old Y. Cool. 270 is...
Wait.
Y is becoming the old X, right? And X is becoming the old Y minus old Y. Cool. Makes sense.
Yeah, it does. Do you want to maybe print these values just to see what it does?
Yeah,
the northeast, south, and west. Sorry, can I see the northeast, southwest for the?
Of course.
Okay, so transform north, sum, cool.
It's
subtract,
plus.
Cool. East. But east. No, north and south are for in Y for us, and east and west are in X for us.
You are 100% correct.
Why did we do that?
Because we're calculating the Manhattan distance. It didn't fail the last time.
Being the Manhattan distance, there is no difference if you move the ship. It's just being no difference. But for the vector, it's different.
It does. This is a
very good catch. Yeah, that's
nice. Let's see what it does now. Yeah, it passes. Ooh, so let's modify the ship, I would suggest.
Thank you.
Well done, Robert.
Okay, yeah, actually very well done. So, north.
But well, for the ship, I don't know if it's changing something due to the fact that we are giving the Manhattan distance.
I'm curious if test 1...
if the first one still works.
Exactly.
Yeah, good point.
This self-direction, okay, this is still correct. Okay, let's try it. That should be the only change. Well, where is it? Here it is, part 1.
I have no idea if you still work. Okay, I still work.
Yeah, both of them still work. Okay, wonderful.
Copy and paste, kill it again, the code.
Yeah, exactly. Well, it was already broken.
Yeah, but copy and paste is the evil. Is evil. You don't have to copy and paste. Always write everything.
I'm going to commit this. Switch and S motion north south / east west motion to the correct affect the correct axis. Cool. Yay, we fixed it.
Okay, this one was easy. What can we do next? Shall we try to improve something there?
We were talking about improvements. Right now, the loop is simple in 190, 191. We passed both discussion to both the actor of our simulation, and they react in the right way. I don't know if here there is a cleaner way of doing, because probably this can be a little bit magical, scriptic, understanding this, or if it's fine. I don't know if it's simpler to have an if here that say if forward, work on the ship, if else, so if it's not forward, work on the waypoint. But in the end, the match with the match is
doing the same if statement.
It's doing this if for us. I don't know from the performance point of view.
It's just doing once more, but I don't think that's gonna make a hell of a lot of a difference, right? Because we are applying the match twice, one for the waypoint and one for the
ship. But the ship is on matching when it's forward.
Even so, we're still gonna need to check it twice. So
no, because if you do an if else type of match, then in one branch you'll call the waypoint, and in the other you'll call the ship.
Yeah.
So you only do one comparison, basically.
You still do two comparisons because we have to do a comparison here, right?
and one inside the match. Yeah, that's fair.
exactly.
Yeah, but
So-
you remove one comparison inside the ship, because of that ship at that point the ship know that is only called on forward, and you don't have to pass the extraction anymore. You just have to pass the waypoint and the extraction value to the
Well-
apply waypoint. So you have
Yeah.
one less match inside the ship, but you have one
That's
more
true.
match inside the loop. So in the end, it's still one if that you are doing somewhere. It's just that you move the place from here to the ship.
Mhm.
I don't know what is easiest to read or less cryptical.
It's easier to understand what the intention is if we put it here at the control point, I think, because if we say here instruction dot, what was it, action,
Mhm.
double equal. I don't even remember how to do an if
Yeah,
statement in
that's
Rust.
not gonna work.
How do you do this? I can't remember. We've
You
used
need
it
to
before.
do if
We can do another match instruction
let-
action forward called the ship, else underline called the waypoint. But well,
action column with
Ah.
uppercase A.
Sorry, yes, doing it now. Action column forward
Equal that instruction dot whatever.
instruction dot action. Action.
And now you can put curly brackets and else.
This is ship. Else. And we'll need, oh, whoops, sorry.
yeah, at this point, the apply waypoint can become apply waypoint instruction value. not
Yeah, this is
instruction,
going to be instruction dot value with a dot, sorry.
as ref. No, but well, we can pass it. At
We
this
don't
point.
care. And this is
At this
going to
point,
be distance count multiplier.
A multiplier that is I32, U32. What the fuck is
I don't remember if it was.
I don't remember if he signed it or unsigned it. I have no. What the...
Don't remember.
Let's look for instruction.
U32.
I think it's a
U32.
U32, yeah.
Okay, and oh man, I'm lost. Sorry. Apply waypoint. So U32.
And then you have to
Basically,
multiply.
you replace the instruction value with multiplier.
Hang on, we don't need any of this
No,
anymore.
you can remove everything and leave just the self x and the self. And the instruction value now is multiplier
It's just multiplier, yeah.
as E32, because otherwise he's complaining.
Yep, for some reason. Okay. Seems happier. Let's see if it's complaining at point of E.
Yeah, at this point also the instruction can be not borrowed in line 186.
Type annotations.
Type annotation, type.
This guy, but it's already inferring it here.
What is complaining about?
Consider giving instruction a type.
That's
Why?
interesting.
Why?
If you put parentheses.
Because we're not telling it specifically that we want this parsed as an instruction.
But well, in line 182, if you do colon instruction, what is doing?
Oh, because before we were passing it to a function, so it was figuring out. But
So
now, since it's not always passed to that function.
Yeah, it seems happy now.
Yeah. Okay.
Also, I was saying that now in line 186, we can pass not the reference to the instruction, but the instruction, because we need it only once.
You are absolutely correct.
I don't know if from the memory point of view this is going to be more efficient, because it's going to unallocate the memory after the call. No idea, but well. Okay, the tests are still green. The tests.
Let's see. So let's start with part one, although this should be fine because we haven't touched it. It is.
Yeah, but tests are meant to be run, so.
Yeah, it's still fine.
Nice.
It's all good.
I think this is more readable, to be honest.
Yeah. It definitely clarifies our intention. It's like, if we, it says that you only move the ship when the instruction is to go forward.
Yeah, otherwise we mutate the waypoint.
Exactly. So this is good.
Sounds good. I think we by the way, we are getting close to the 1 hour mark. So we have 4
Alright.
additional minutes. If I don't know, there is anything
Do we
else
want to
worth.
handle this anymore? We don't, right?
No, because we are.
Yes, but if you remove that, we still need to provide
An
a
underscore,
default
right?
to kind of.
And to go, how was that unreachable, right?
No,
This-
this will.
It is
Oh yes,
technically.
this will be reachable because we are not
Oh, it is.
calling it anymore when it is forward. Yes.
Yeah,
So
we have the
technically
if
could
in
be
the main
reachable,
loop.
but we are not calling it.
Yeah,
Right?
exactly.
We have the if in the main loop that is preventing
Yeah.
us from calling it
Let's
with that
see.
parameter.
Let's see if the compiler agrees with us. It does. Cool. So that's
Yeah, I don't know though if the previous code was a little bit more defensive. Because if you call it directly with that value, it will panic.
That's true.
So
But probably
maybe
it's
I'll
good
prefer
because
this
you don't have to call the waypoint with a forward.
It shouldn't be actually. Yeah, you want it to panic because
You
it's
want
like
okay,
hey,
then let's leave it forward and maybe let's just panic explicitly.
Yeah,
there was a way to.
or we do a type, a subset of instruction, a subset of the num instruction that is just the instruction for the waypoint and the instruction for the ship, and then we do an union of them. But okay,
I think.
Yeah, that will be, I think, from a
Overkill.
typing perspective,
more correct.
but it's probably too much for now.
Because there are
Okay.
waypoint instruction and ship instructions.
Mm-hmm.
Then when
Yep.
you parse them, you have to give back a ship instruction or waypoint instructions, and then you call the if will be on the type of the instruction and no more on the type of the instruction action of the
Yes.
value
The
instruction
problem
action.
is that will break part 1. So let's keep
Yeah,
it simple.
and also I
Yeah.
think you need the drugs to do that, just to keep
Yeah,
everything
default for
in your
ship.
mind.
Let's have a look at the to-dos and see if there's anything. So implement default for ship.
Oh, the
What
default might be interesting one.
default what?
So this is Rust convention, I'd say. So basically,
Okay.
specific types can have like a default value, let's say, for that type. And every time you have a type that has a new method and that new method doesn't take any argument, basically Rust is telling you, okay, that means that you have a default value for that type. Because if you don't need any parameters to initialize a type, that means that you have effectively a default.
Yeah, your constructor is without parameters.
Exactly. So there is a more explicit trait that is literally called default
Okay.
that express that idea.
Which
And basically what we can do, we can say implement default for ship.
so we'll do that after. Actually, I'll remove the to-do since we're doing it. I don't know VS Code, sorry. So in default for
Which-
You don't
ship-
have to know VS Code. VS Code could know you.
Yeah, no, I was looking for the jump to ending bracket, and I'm like, how did you do that here? It's
You
not
scroll.
happy with this. All trait.
We have to import the default somewhere.
No. Missing default and implementation. So I
Yeah, now
suppose-
that we need to provide the function that is
let's
expected,
do
which
the quick
is
fix.
oh yeah, let's
This
do the
guy.
quick fix, which that it is, and basically
Okay,
we can
so-
just call ship column new or copy that new into there and remove the new, which I think is even more idiomatic.
Okay.
You remove the new because you have a default that is returning the default
Exactly.
stuff.
So the new is just a convenience to pass parameters.
Okay,
basically.
and then how do you initialize the ship
this?
now?
Exactly, that's it. And
How
now
do
you
you
just call
initialize?
ship column default.
Instead
Down
of,
with it. Ship
instead
new.
of new.
Okay. And why
Okay.
this is better?
It's so there is another way. I think it's
Let's
better because
test
it's just a way to say that that type has a default implementation, so you can have a default value for that type.
Probably
And
part
it-
1 is broken down.
I don't think so. No.
Okay.
So another way that you could do that is by using that return type inference. So you could say that a ship explicitly, no, not there, where you initialize.
Okay.
That you can
Sorry, yeah.
specify on the left-hand side, you can specify column ship to say that it is a ship.
Okay.
And then you can say default equal default column. So rather than using ship there, you just use default. And I think you need to use the namespace as well. So it's default column default as a function. Unless, yeah.
Okay.
Okay, cool.
So you can say, just give me the default. So that tray allows you to use this thing everywhere, basically, for every type that has a default.
Okay, now it makes sense.
Yeah. Okay, let's do the other one like this. I'm not used to this kind of syntax, so I'm not yet sure or sold on it. But
yeah, I think it's more of a convention than anything else, to be honest.
It's still clear what it is. I mean, you're clearly defining the type here. It's not like, what kind of default,
Yeah, but think if we declare the function in 173, then we have a function that we pass the ship, and inside that function, they assign default to the ship. But they don't know what type you are passing them because they are accepting, for example, an interface that is implementing default. At that point, you can pass around the variable without caring about its type because you are just implementing interfaces. Yeah. And you can have a function that work on interfaces that instantiate default elements for that object without having to know the exact type. Because a ship default, you are initializing a ship, but then you are preventing the ability to be called with other types. So yeah, I see some scenarios where this can be useful. Not here for sure. Here is just
I think another interesting case could be that, for instance, the waypoint, right, or the ship itself. Maybe in one of the two exercises, rather than starting from the default point, they will start from arbitrary X and Y. So at that point, you could have a new that receives X and Y. But you can have also a default that doesn't need anything. It's just going to be 0, 0.
Yeah.
So it's basically a shortcut for whenever you want to initialize.
Yeah, and in this way, you get rid of the problem of not having default parameters.
Exactly, yes.
Yeah. Sorry, I'm also committing right now. Just so we don't lose this, because if I don't commit now, I will forget.
So this is the documentation for
the trade.
Yep.
I think this is the only to do.
You have to create a banner for the Patreon channel. €5 for your laptop.
Yeah, I need to provide some way to pay this money, right?
Your home address, they can email you money in
an envelope. Yes.
Yeah, in an envelope.
I accept any currency.
Did you check the chat? We got some spam earlier.
Yeah, I blocked that.
Nice. Sorry, I just saw it now. They're very active already.
Okay, so what do we do? Do we leave it at that for today? I don't think it's worth to start another one.
No, I don't even know what is in the 13. We have to start with the 13. Yeah.
Yeah.
Let's prepare it off camera.
All right.
Yes.
I'll stop sharing that.
Let's close it off. I'm just gonna say the usual stuff, which basically is, if you want to see the code, it's available on GitHub here, and there is also a YouTube channel where we have all the recordings, and the YouTube channel, if you're watching now on Twitch, is available in the About section of the Twitch channel. If you're watching this from YouTube in the future, hello from the past, you can watch the next live stream on Twitch, and you can find the link in the YouTube description. We meet every Monday, almost all the time. The schedule is available on Twitch as well. Monday, 5 p.m. GMT. So next time we'll be solving the exercise 13 of year 2020 of Advent of Code.
we are optimists. We are going to solve. We are going to try to solve.
Try, yes.
Let's see how far we get. Are you gonna do the raid thing, Luciano? Or whatever it
We
was
can
called?
try. Right now we have only one viewer, so I don't know if it's gonna make a lot of a
Alright.
difference. But
Fair enough.
we can
Hello, one
probably
viewer, thank you.
try. Let's see. Ooh, I cannot do it from here. Can I?
We'll leave them alone then, I guess.
Yeah. Okay, give me 1 second. I'm gonna try. Well, I think I can do it even after the stream is over. So we are just gonna leave it at that and just say thank you, everyone. And yeah, thank you also, Roberto and Eugen. We'll see you next time.
See you next
Thanks.
time.
See you next week. Bye.
Remember the €5.
I'll revel at you later. Bye, guys.